All right, here we go. Applications now. So math would sort of be a pointless study if it didn't have any applications to real life. There are people who study math just for math's sake, but the practical application is that math should be applied to something that you actually use. I have watched Mr. Baker teach his lesson on equilibrium points, on like the break-even point of revenue and cost. So we're going to talk about the math behind that today. All right, so equilibrium, if you've taken econ with Mr. Baker, you've talked about that. Okay, you've talked about how you'll have a revenue line that will go up like this, and then you will have a cost line that will go down like that, and then you shift them, and you maybe move one up, and then it looks like that, and maybe you shift the other one sideways, or it shifts up and it moves like that, and then you have a new equilibrium point. Yes, you've seen all these graphs that Mr. Baker has done? Okay. All right. So equilibrium in economics is the mathematics of when cost and revenue are equal. All right, so equilibrium is setting cost equal to revenue. So juniors, you have that to look forward to next year. All right, setting cost equal to revenue. It's also called the break-even point. Okay, the break-even point. All right, so we're going to do an application problem. We're going to see how a system would work for this. Okay, how a system would work. So let's suppose in your example that your business has manufacturing costs of 65 cents per item. So that's how much it costs you to make it. You got to go buy the materials, and to make one of them, it costs 65 cents. Now, you're not just going to make one. You're going to make hundreds and thousands. But to make one, that's how much it would cost. You might have fixed costs of $10,000 to get you started in your new business. Your generation, the millennials, tends to be people who are not afraid to start new businesses. Tons of startup businesses, you know, hey, I'm going to sell this, or I'm going to have this idea, I'm going to make this app, I'm going to make this product, and I'm going to put it online and sell it. So there is a very good chance that there will be people in here that are entrepreneurs, okay, that become entrepreneurs. All right. Now, you can't just have costs, you have to have revenue. And so you'll have revenue income, money coming in. Okay, that has to do with what you sell it as. And so your revenue income is going to be $1.50 per item. So you can tell that what the margin of profit is per each item, but you got to pay off all of your costs that you had. That $10,000 that you had in fixed costs, maybe that was your rent, it was your advertising, it's your insurance you got to take out. So you have $10,000 of costs, and you have your manufacturing costs, and you got to start selling stuff. Okay, so yes, you have a profit on each thing, but you still have to pay off the debt of your $10,000 first. So let's find the equilibrium. Okay, to find the equilibrium, another word for revenue is, well, yeah, we can get into profit later, but let's just start with finding the equilibrium. So you need to set up a system. And your system is going to be a cost and a revenue system. Okay, a system has to be two equations, so you need a separate equation, one for the cost and one for the revenue. The manufacturing cost is 65 cents per item, so you write that 0.065, but then you need an X on it. Why? Because per item, it's not just 65 cents and you're done. It's 65 cents every item that you make, and so you have to have multiplication involved. Plus the $10,000 that you had as your fixed cost. The revenue is 150X. Again, per item. One of the most common mistakes is people not to put the X's. Okay, they just leave them off altogether. All right, and then to find the equilibrium, you're going to set the cost equal to the revenue, and then you just do the math of solving. So we're going to set cost 0.065x plus 10,000 equal to 1.50x, and then we just have, then you're in the home stretch. Okay, then it's easy from there to solve that. Okay, so we want to get x by itself, and since there's an x on each side, we need to subtract to make that happen. All right, so we end up with 10,000 equals 0.85x, and then that's why I had you leave your calculators on your desk, because you'll need that to be able to determine what the x is. So you'll use division. Somebody type that in for me. You've got your calculator out. So we need a 10,000 divided by a 0.85. Say it again, Annika. 64 point. So we're going to round to 65. What are the units on x? Not dollars. Okay, not dollars. Okay, not cents either. Okay. Is that a what? It's nothing. Okay, well, what did x stand for? Let's look back here. Okay, why did we put the x there? X stands for the item, and so this is the item. So what does that mean?
Oh, you need to sell
You need to make and sell, okay? Make and sell 11,765 of your item, whatever you're selling, bath bombs, you're making them in your kitchen or something, I don't know, okay? Chocolate covered pretzels, whatever you are selling, okay? Just to break even. That is equilibrium. What if you sell 11,766 items? That means you finally made profit. Okay, if once you sell the 66, 11,766, you'll finally make a profit. You have to sell 11,765 just to break even. So most young entrepreneurs, it takes them, they say you have to take at least plan on 3 years before you'll break even. If you break even sooner than 3 years, great. But 3 years is, stick with it if you're doing a new business plan. If after 3 years you're not close to breaking even, it's probably time to either restructure or cut your losses and close your business. But don't expect to make a profit in the first month or the first 6 months even. All right, next equation, next problem. All right, design a rectangle . All right, with perimeter 100 feet and area 600 feet squared. Okay, design a rectangle with perimeter 100 feet and area 600 feet squared. All right, so we're going to design a rectangle, base and height for my rectangle, and it needs to be such that I meet all of the requirements. So this is a system as well. The system, remember, every system has to have 2 equations. One equation for what? What are my 2 different equations going to be? One for perimeter, one for area. Okay, I need 2 equations, one for each of the things that's described. All right, does anybody want to take one of those? Take either the equation for the perimeter or the equation for the area? Okay, I heard a couple mumbling. Somebody, you're doing which one? Perimeter. Okay, 2b, or not, plus 2h equals 100. Yeah, we know the perimeter has to be 100. So perimeter is the area all around. So when we add up all the, we have 2 bases and 2 heights all the way around. So that has to be 100. All right, what's my second equation that has to describe the area then? BH, okay, B multiplied by H, and that has to equal 600. All right, so there's your system. Once you get that, now you're kind of in the home stretch of solving it. You can choose substitution, elimination, graphing, your choice of how you want to solve this. All right, so somebody pick a method for me.
Substitution.
Okay, what do you want to get alone then? You got to get a variable alone. Which b, the top or the bottom? She wants to get the bottom b alone, sounds fine. I could work with the top b getting alone too, it doesn't matter. Okay, both are going to be fine. So if you get the bottom b alone, Annika, what do you have? B equals, not 600 times h. How do I get divided by? All right, so in order to get that b alone, I have to divide both sides by h. What I do with that b is I'm going to take it and I'm going to substitute it back into the other place where b was. So this will give me 2 parentheses, 600 over h plus 2h equals 100. So I clean up the multiplication of 2 times 600, that's 1200 over h plus 2h equals 100. All right, how do I solve that problem? My goal is to try and figure out what h is. Again, this is going back to like first semester. So yesterday we had to remember things like quadratic formula and factoring. What do we have to remember about this? Nice job. Okay, multiply everything by h. All right, if you have a denominator there that doesn't belong with any of the other ones, then multiply the whole problem by the letter h, which means distributing. So we distribute, I'll go this way. We distribute, and we distribute again, and we distribute all the way over to the 100. That will give me 1200h. It will give me 2h with a squared on it, and it will give me 100. I take it back. The 1200 does not have an h on it. It reduced away. Okay, now we have a squared problem. Okay, I can't factor it yet because it's not equal to what? It's not equal to 0. I need to make it be equal to 0. So 2h squared minus the 100 plus the 1200. Put it all in the right order and make sure it's equal to 0. Now I can use factoring or my quadratic formula or whatever. Let's stick with factoring or graphing. Any of those is going to work, but we'll do what do they have in common all the way through? The number 2. Okay, everything is even, and so 2 could come out. That gives me h squared minus 50h plus 600, which means I can star factor, and I'd have 600 on the top and negative 50 on the bottom. I'm sure if you thought about that long enough, you could come up with negative 20 and negative 30. Just think about what would make 6 and 5. And hopefully that would also, so that would be negative 2 and negative 3, and so you got negative 20 and negative 30. If you could not come up with it, if you thought about it and you thought about it and you could not come up with star factor numbers, what can you always do? You can always do quadratic formula. But hopefully you come up with the negative 20h and the negative 30h, and you're able to split this down the center. So taking an h out leaves me with h minus 20. And taking a taking a negative 30 out leaves me with h minus 20. So I've got h minus 20, and I have h minus 30, and I have the 2 from before, and all of that is set equal to 0. So 2 equals 0, h minus 20 equals 0, h minus 30 equals 0. So I get 2 answers for h. It could either be 20 or 30 feet. So when you design your rectangle, it could either be a rectangle that was 20 feet high, or it could be a rectangle that was 30 feet high. What other dimension do I need? I need the base. So the base is what Annika got for us at the beginning. The base is, I'll put red around it here. Okay, the base is 600 divided by whatever h was. So if you know what h is, you take 600 and you can figure out what the base is. So I have, for this one, it would be 600 divided by 20, and the base would be 30 feet. For the other one, it would be 600 divided by 30, which would work out to be 20 feet. What do you notice about these dimensions? If the height is 20, the base is 30, and if the height is 30, the base is 20. What does that mean about your design? Well, either it looks like this, and it's 30 by 20, or it's turned on its side and it's 20 by 30. So either way, you have a rectangle that's meeting the requirements. Okay, yeah. Scroll up a little more.
Thank you.
Okay, next one. Could you just double check your calculators and make sure it's set to standard window before we do our next question? All right, next question or questions. All right, graph to find the solutions. I'm going to give you two questions here. 3x plus 2y equals 6, and y equals ln x minus 2. And the other equation is 3x minus 2y equals 0, and x squared plus y squared equals 4. All right, two problems in one. If you are going to graph to solve, what format do the systems have to be in? They have to be in y equals. So in all of these, really only one of them is ready. The natural log one is good. In the top equation, it is not in y equals format. So your job would be, come on, okay, to rearrange so that you had y by itself. You need to work towards getting y alone. So in this equation, y1 by itself would turn out to be negative 3 over 2x plus 2. That's when I get, plus 3. When I get y by itself. Okay, you should know how to do getting y by itself. Yes?
Is it okay if I had 3 minus 3 over 2x?
Negative, yeah, that's fine. 3, no, not over 2x. You can have
2 and then times that.
You can have 3 minus 3x all over 2. Right, and then this would be y2, would be ln x minus 2. What I really want to practice with you is the bottom equation. All right, so let's really focus on that one. In the top equation, what do I do to get x by itself, or to get y by itself? What do I need to do? Okay, subtract 3x. So I'm going to have subtracted 3x to both sides, and then what? Divide by negative 2. So that will give me y1 equals positive 3 over 2x, because the two negatives make a positive. All right, how about the bottom equation? Okay, she says subtract x squared, which is good. Okay, I'll buy that. Then what? Okay, take the square root. And what do you have to remember? So I am going to have a y2 and a y3. Okay, y2 is the positive square root of 4 minus x squared. The square root covers everything. It covers all the way across the 4 minus the x squared. In the y3, we're going to have negative square root of 4 minus x squared. So what I would like you to do right now is graph those three, turn your calculator around, and show me what you have for a picture. Okay, what you guys are seeing is a line intersecting a semicircle and another semicircle. All right, so you've copied this onto your paper. We have this line, and which equation does that coordinate with in the, that's y1. Okay, and then you had this upper semicircle, and which one is that? No, that is because it's on the top. That's the y2. So this is where y1 and y2 cross each other. And then this one right here, that's which one? That's the y3. And so this dot is where what two things cross each other? y1 and y3. All right, so this one, is y1 intersecting y3 right there. And this one right here is y1 intersecting y2. Okay, now we're going to start with y1 and y3 because that's the harder one to do. So let me switch over.